Today we are going to learn how to convert the flying wedge to a Newman projection formula. To understand that, first we need to understand what does flying wedge represents. Flying wedge represents three-dimensional molecule in 2D, where we know that the carbon is, for the tetrahedral carbon, two bonds are in the plane. One of the bonds is towards the observer, coming out of the plane, represented by a solid wedge. The fourth is away from the observer with a dashed wedge. The solid wedge and the dashed wedge, they should always be next to each other, and never ever you can draw it like in between these two bonds. That is incorrect representation, right? Now, for this flying wedge, we are going to depict the hydrogens, and for Newman projection, we have to see the molecule along the longitudinal axis. So we are observing on this axis. So this is our front carbon, where the methyl is facing downwards. For the back carbon, methyl is facing upwards. Let's draw that. Back carbon, front carbon. For front carbon, methyl is down, so the other two bonds would be like this. For the back carbon, methyl is up, so the other two bonds would be this way, right? Now, look the molecule from this side. So chlorine is coming out of the plane towards the observer. If observer is standing here, so chlorine would be on its on their right hand side, while hydrogen, which is below the plane, would be on the left hand side, right? So chlorine on the right side, hydrogen on the left side. On similar lines, if you look to the back carbon, chlorine is again coming out of the plane towards the observer, so on right hand side of the observer, while hydrogen would be on the left hand side. So chlorine, hydrogen. So this is methyl and that's also methyl. This is how you convert the flying wedge to the Newman.